Hi guys, so today I'm just going to be going briefly through how you should go about installing the underlying source codes for MAGEMin in order to run calculations with the Green et al. 2025 or Weller et al. 2024 thermodynamic models. Essentially, if you want to run your calculations with thermodynamic models that are not part of the MELTS family and instead want to test your calculations with thermodynamic models developed by the Tim Holland Roger Powell group, then this is how you should be going about doing that. And as before, the first thing you want to do is you want to go to the PetThermoTools read the docs page. And in this case, you're going to get onto this thing on the left here, running MAGEMin calculations through Julia. And you're going to click on that. And essentially, this is going to be very similar to the installation instructions for alpha melts for Python, just with a few subtle changes. But before I go through these instructions, we should first talk about what MAGEMin is itself. So MAGEMin was released back in 2022 alongside this paper. The lead kind of developer for MAGEMin, Nicholas Reel. And this software MAGEMin is written primarily in C, but it's wrappers in Julia. And it is a Gibbs free energy minimizer. So essentially what it's doing is you give it a composition, a pressure, a temperature, and it's finding the minimum Gibbs free energy of the system at that for that PTX conditions. So it's working in similar ways. The minimization algorithms are slightly different, but it's working essentially under the same idea as MELTS. But the important thing here is that it doesn't actually use the MELTS models. It uses an alternative group of thermodynamic models, and through PetThermoTools, we can access both the Weller et al. 2024 and the Green et al. 2025 thermodynamic models. These are both based primarily on some of the earlier Tim Holland thermodynamic models. So MAGEMin itself, you can find it on their GitHub page here. And you can, if you wanted to run MAGEMin yourself, you can. You have to have some understanding of Julia in order to unlock and use the Julia interface to MAGEMin C. There is also a MAGEMin app, whereas if you're just looking to run some phase diagram calculations and things like that, you can follow their instructions on the MAGEMin app GitHub page for how to download and run calculations through the MAGEMin app. But the point of developing this as part of PetThermoTools is that you could run calculations with MAGEMin, and you can run calculations with MELTS, and you can compare the two. You have them in the same place as part of the same Python notebook. Now, one of the challenges with this was actually setting up a way to connect Python to Julia, to connect Python to the functions for MAGEMin that are written in Julia. Okay? And that's basically what this installation notebook is going to walk you through. It's going to walk you through how to go and install the relative bits that you need in order to kind of establish that Python Julia connection and then run calculations through Julia from that point onwards. So once you're in the R read the docs page and you come down to this running MAGEMin calculations through Julia, you can obviously read through all the information that I've given you here if you want to learn more about why you might want to use MAGEMin and what we've done in order to get this working in Python. Okay. But really the key thing that you need to do is actually download the notebook. So you can do that here. Just click this View and MB Viewer button here. It will open up a separate page. And what you want to do is you want to right click if you're on Windows, or if you're on Mac, control click, download notebook, and hit Save Link As. So hit Save Link As and you find a folder somewhere on your computer that you think is probably relatively good for it. For me, I'm going to put it in my GitHub folder where I have some of this stuff stored already. Okay, I'm going to put it in here and then save that in. Okay, so you download that file, you save it onto your computer. You then come into your code editing software. I use Visual Studio Code. Other people, you might be running this in a Jupyter notebook. Yeah, all of this should work. All you want you to do is you want you to then go and find that file that you just downloaded. So I want you to go and find in your file directory, I want you to find the file that you just downloaded. So it should be called this MAGEMin Python call. Okay. So you're going to open that up in whatever software you're using for code editing. And the first thing we need to do is we need to install Julia. I actually suggest in later versions of Python, you're going to have to do this with a % symbol rather than exclamation mark. But you want to run this function here. I'm not going to run it because I already have Julia call installed, so it's not necessary. But you'll just hit Control Return or Command Return in order to run this cell, and that will install Julia call. And Julia call is basically the package which is allowing us to set up the connection between PetThermoTools, and Julia, between Python and Julia, I should say. The next step we need to do is, firstly, if you don't have PetThermoTools installed, uncomment this line and uncomment this line here and install PetThermoTools. A good bit of advice is probably to upgrade PetThermoTools at this point as well, to make sure you're getting the latest version of PetThermoTools and therefore the latest version of MageMin. Okay, so you want to install PetThermoTools, or if you've already done that and you've already installed JuliaCool, all you really need to do is import PetThermoTools. Make sure we're using the correct Python environment, import PetThermoTools, and check the version number. If you're watching this video, you should be at least on version 0.3.1 or later. The next thing you want to do is you want to uncomment this line here and allow it to run. And this is basically a function within PetThermoTools, which is going to install MageMin. Okay, so what it's going to do is it's actually going to set up a separate Jupyter environment on your machine. And in that Jupyter environment, it's going to install all the Julia packages that are required for running MAGEMin calculations. This is going to include my own package called MAGEMinCalc, MAGEMin calculations essentially, and the underlying MAGEMinC package, which is the Julia code written by Nicholas Reel. Okay. So this function is just one function. You don't have to put any arguments in or all. You just need to run it. It's going to download this and set it up for you. Okay, so let's run that here. And it should print that message. So if you do have any issues with installation, please contact me. There are definitely still bugs in the code at points. I'm trying to iron them all out as much as possible, and it really kind of depends on you guys giving me as much help as possible, just letting me know where things break down. Okay, so you can see it's doing various things. I actually already have this project made, but if you don't, it will make a new project, PetThermoTools Julia environment. Okay. And it's going to update the project.toml and the manifest.toml files of that environment. Okay. It's also going to make sure we have the correct things installed. So it's going to make sure we have the latest or the most up-to-date version of MageMinC that I have tested alongside my code, so I know works with my code. It's going to then install the latest version that I know works of MAGEMinCalc. This is my Julia package, which runs the calculations in MageMin. Okay. So I'm going to make sure we have various other dependencies installed, and this process can take a little bit of time. Okay, so it's going through and it's installing all of these things. This can take a little bit of time, maybe a couple of minutes. I wouldn't worry if it's taking a little bit longer. It can be quite slow. Okay, actually establishing that connection, that JuliaCool extension, can in itself take a reasonably long amount of time, maybe up to 30 seconds before you even start to get any of the installation processes running. But fingers crossed, you should be able to run this line here and nothing else is going to be necessary. Everything else should run smoothly. Okay. So we're going to move down and talk about what's happening next. Okay, so whilst this is continuing to install, I'm going to allow all these packages we're setting up a new Julia environment here and installing everything we're going to need in that Julia environment. Whilst it's happening, I'm going to talk about this cell here. What will happen if you're using MageMin through PetThermoTools is at some point in the future, I will push an update to PetThermoTools. And that update will no longer work with the version of MAGEMinCalc and the version of MageMin itself that you have installed in your Julia environment. Okay. And that's just part of kind of developing open source software in this case, that I'm going to develop new functions and new capabilities within functions. And as you update PetThermoTools, I haven't yet found a way for it to automatically update MAGEMinCalc and MageMin itself in the Julia environment that we're establishing right now. Okay. So what I suggest is every time you pip install upgrade PetThermoTools, come back to this notebook. Come back to this notebook, uncomment this line, and run this line, and it will update MAGEMinCalc and MageMin to the latest up-to-date versions that I know work with PetThermoTools. Okay. So if there's been no changes to MAGEMinCalc, say I pushed a small update to PetThermoTools, you pip install upgrade and have that small update. If there's no update to MAGEMinCalc and you run this function, it's just going to do nothing. It might take a minute to check, but it's going to do nothing. But in cases where there is an update to MAGEMinCalc, running this function is going to be necessary. So as a general rule, if you pip install upgrade PetThermoTools, come back to this notebook and run this function in here. That's all you're going to need to do in order to update MAGEMinCalc. Okay. So I'm not going to run it. This is just finished running. You can see actually in my case, because I already had this installed, there are no changes. But what we actually, for you guys, it would have installed the new, set up a new Julia environment, and within that Julia environment installed MAGEMinCalc and MAGEMin. You can test this. Relatively easy test. We just have a test MAGEMinCalc function. Okay. And all it's going to do is it's going to take a fractional crystallization calculation using the composition of estimated composition from salted crust, essentially. And it's just going to run a simple crystallization calculation. I can't remember off the top of my head exactly what parameters I've chosen in this, but it should be relatively straightforward. On my Mac, it takes around 30 to 40 seconds. As I said before, the majority of that time is initiating the Julia call extension. Okay, I reckon around of that 31.1 seconds, probably around 29 seconds of that is establishing the Julia call extension and activating that project. Actually running the MAGEMin calculations is incredibly fast. Now you'll see it should print an output that looks something like this. You'll see that actually for the outputs, MAGEMin normalizes everything to 1. So this is like a weight fraction of the liquid at each step of the calculation. That's what's being shown here. Okay. Don't worry too much about those results. It should print something that looks very similar or ideally identical to this. Depending on exactly when you run this, it might change slightly in the future. Okay, but I've got it set up so if it's successful, it will just print an output table like this. That's basically what you're looking for. Okay, we can then test it's really worked and test it's working correctly with our version of PetThermoTools. To do that, we just want to restart our kernel, re-import PetThermoTools, and then we're going to run this calculation here. Okay, so once again, taking like an average basaltic composition, and I'm just going to run a simple isobaric crystallization calculation using that composition, the Green et al. 2025 thermodynamic model, and we run it at 1,000 bars. Okay, so we can run that. Once again, once we restart the kernel and reinitialize Julia and MAGEMin, it can take a little bit of time to actually establish that Julia call extension, activate the project, and import all the Julia packages that are required in order to run the calculations. Okay, so it may take around, once again, 25 seconds until the calculations actually start. But once the calculations start, these calculations are quite quick. So in a second or two, this should hopefully finish. And then we can move on to the cell below. There we go, cell below, which is just going to once again test the results. And so if you watch any of the other videos, you should have seen how we kind of organize our outputs. And it's exactly the same regardless of whether we're using MAGEMin or whether we're using melts. There's an output table for conditions for each phase that stabilizes, both the composition and the properties of that phase. Okay. And so say we wanted to look at the liquid composition, we could do that there. And the column headers here will be the same regardless of whether you use MAGEMin or melts. So say we want to look at the properties of the liquid, we can do that. We can look at the mass in grams. We assume our system starts with 100 grams of substance in the system, and it will decrease from there. We can look at the density of the liquid, the volume, the enthalpy, the entropy, etc. Okay. But what we're going to do down here is we're just going to take the magnesium content of the liquid and plot it against the iron content of the liquid. And once again, if everything's gone well, if MAGEMin has been installed correctly on your machine, you should be able to run that and you should end up with a graph that looks like this. In step 5, you're now ready to use MAGEMin alongside PetThermoTools in your research. Thanks a lot for listening.